Section 9.6 is another section on a special pattern of factoring, and this is called perfect squares. So again, we're going to look back to a special pattern that we used for multiplication when we had a plus b squared and a minus d squared. Let me see what I did here. Yeah. So when we had this, sorry about that, if I multiplied a binomial squared, I got a squared plus 2 times the middle plus b squared. The same thing happened with a minus b. The only difference was that the middle term was also negative. So what we're going to look for in factoring, starting with the trinomial and going to the factors, is this pattern where, sorry about that, where the first term is squared, the last term is squared, and the middle is twice as much as the square roots multiplied together. Let's look at this with something a little bit more concrete. So if a trinomial is written in the form a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, then it can be factored as a plus b squared or a minus b squared. In other words, when I multiply this, I get this. So when I factor the trinomial, I will get the binomial squared. The same for our negatives. Okay, let's try one. So I look at this trinomial before I start to factor it, and I first say, this is a perfect square for x squared. This is a perfect square, 8 squared. And if I multiply 4 times 8, or 4x times 8, I get, oh, sorry, there's something wrong here. That is incorrect. I do. I've probably done something wrong here. This is the example out of the book, but it's not a good example. Oh, yeah, that's because they said this is one that doesn't work. Well, okay. So 4x times 8 times 2 does not equal the middle. So this cannot be factored using our special pattern. Let's try one that can. Okay. Perfect square, 3x. Perfect square, 2 times 2. If the middle is 3x times 2, our two pieces, times 2 again, which it is, we can use our special pattern. So the special pattern says I take the a term, 3x, I use a minus because of the sign in the trinomial, minus 3x, minus my 2 from here, and I square it. So again, looking for the special pattern, perfect square, the middle being 2 times the square roots multiplied together, I can use this pattern for my factoring. Let's try another one. Perfect square, 5x, square root of 1 is 1. So I do have perfect squares on the ends. 5x times 1 is 5x, and if I double it, I do get the middle. So using my 5x and my 1 with a minus sign, I can factor it very quickly and neatly. So let me go back 1 minute. So the key here is to trinomials. And when we did our multiplication of a binomial squared, I told you that it was important to begin to learn the pattern, x squared, 6 times x doubled up, and then squaring the last. And I told you it was important to learn the special pattern because when we go to factoring, this makes it easier to factor. Perfect square, the middle is 2 times the outside portions, and we can factor very easily. All right, so let's look at a summary of all of our factoring so far. First, always look for a greatest common factor. If you can pull out a greatest common factor, everything will be simpler. Secondly, look at how many terms. If you have 2 terms and you've already pulled out the greatest common factor, we're going to look for that difference of squares special pattern. That x squared minus 9, it factors to x minus 3x plus 3. If there are three terms, there are three situations. First is simple trinomial factoring, a leading coefficient of 1, not perfect squares, but where the factors of 8 add up to 6, x plus 4, x plus 2. The second for three terms is split the middle, and that's when I have a leading coefficient other than 1. So something like 2x squared plus 6x plus 4, where I have to look for factors of 8 that split the middle. And then I do my grouping. Not going to finish that off, but that's my split the middle. The third thing to do with three terms is to look for the special patterns. A squared plus 2ab plus b squared that we just looked at. So when you have a three term to factor, again, first look for the GCF, then look to see, does it follow the special pattern? Does it have a leading coefficient of 1, or does it have a leading coefficient of something other than 1? And that determines which method I use. If there are 4 or more terms, again, first look for the GCF, and after that, we're going to do our grouping. So you've got a lot of different factoring tools. We've been working on them for a while, but it's important that you know what you're looking for when you first see a polynomial to factor. So let's try a couple of these. Factoring completely. So the first thing I look at, it's a binomial, and I look to pull out a GCF. 4 can be factored out. Now I look at what's remaining. If it's a binomial, my only choice is that difference of perfect squares. And in this case, I do have x squared minus 3 squared. So I use my conjugates, x minus 3, x plus 3. Okay, three terms. Again, the first thing I want to look for is a common factor. It looks like all of them are divisible by 2 and x. So if I factor out a 2x, I have 25x squared plus 5x minus 6. Something happened here. My apologies. That should have been a 14. Nope. That should have been an 18. Leaving me it with, I'm sorry, I'm going to have to do this. Something went wrong and I'm not working it out right. Actually, let's just do it this way. Pull out my 2x, 25x squared plus 5x minus 6. Are there factors of 25 times 6, which is 150, that add up to 5? Let's try 15 and 10. 1 plus 1 minus. So let's do our split the middle. 25x squared plus 15x minus 10x minus 6. Pulling out a common factor. Don't forget the 2x we did at the very beginning. 5x times 5x plus 3 minus 2. 5x plus 3, and my final regrouping. 2x, the 5x minus 2 goes together, and the 5x plus 3 goes together. Okay, so even I got confused on that one. I thought we were going to get a difference. I thought we were going to get a perfect squares there, and we did not. But that's okay. Pulled out my common factor. My split off. Okay, the last thing we'll look at is solving equations. We've been working on this before. Anything equal to 0 can be solved. We're now going to look at the square root property, which is another way to solve these. It says for any number n greater than 0, if x squared equals n, then x equals plus or minus the square root of n. All right, see how this works? So anything squared, I can take the square root of both sides. The square root of anything squared is itself, and this equals plus or minus 7, plus or minus the square root. We'll look in a minute why we need that plus or minus. And then I've got to solve for x, I've got to subtract 4 from both sides. This gives me two solutions. Negative 4 plus 7, which would be 3, or negative 4 minus 7, which would be negative 11. So that can be factored, but instead of having to go through all my factoring, I can just take the square root of both sides. Let's see what would have happened if I had solved this using factoring. So first I have to FOIL this, the 8x. Come on. There we go. Plus 8x plus 16 equals 49. Subtracting 49 from both sides, I'm going to get negative, oh my goodness, things are not going well today. All right, there we go. Negative 33. Factors of 33 that add up to 8 would be 3 and 11, with the 3 being negative, x minus 3, x plus 11, and setting each of these equal to 0, I still get 3 and negative 11, the same two solutions I got over here. Anything squared, I can take. Let's try another one. Now, this one doesn't have a square root, but I see that this is a perfect square trinomial, and this will factor to y minus 2 squared. So again, I can take the square root of both sides, and I get y equals 2 plus or minus 5. So y equals 2 plus 5 is 7, or y equals 2 minus 5, negative 3. So it's a real quick way to solve if I can make one whole side squared. And again, here we have it again, the whole side is squared, so I'm going to take the square root of both sides. The problem here is that the square root of 7 cannot be simplified. But if I subtract 3 to solve for my x, I can leave my answer looking just like this. So I still have two solutions, negative 3 plus the square root of 7, negative 3 minus the square root of 7, and if I had a calculator, I could get a decimal answer. And